Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be looking at how to test four functions. All right, we're going to be given four different functions and different representations: tabular graph, as ordered pairs, and also as a piecewise defined function. And we are to determine which of these representations is actually a function. All right. Okay, so let's take a look at question option 1. We have a tabular representation of a relation. So is this a function or not? So the easy way to determine if a relation presented in a tabular format is a function or not is to focus your attention on the input values. Okay? So you want to make sure that there are no repetitions in the input values. All right, no repetitions. Remember, a function assigns every input to exactly one output. If one input is assigned to two outputs, then it's no longer a function. Okay, so let's take a look at the input values here. -1, there's only one -1. 0, there's only one 0. We have two ones. Bam, bam. All right, so we have 1 going to 1 and 1 going to 2. You have the same inputs going to two different outputs. So this relation is not a function. Not a function. Why? Because there are repetitions in the x's. There are repetitions in the x's. All right. So this particular relation is assigning one input, namely 1, to two different outputs. All right, so let's go ahead and take a look at option number 2. Option number 2 is a piecewise defined function. Basically, you have two functions pieced together. So to take a look at this, if you look at the two functions that are given here, y equals x, we know that's a function because it's a straight line, right? So straight line passes the vertical line test. And then the second function is a parabola or quadratic function. And we know that passes the vertical line test. You might say, well, what is the vertical line test? Vertical line test requires a vertical line to intersect the function only once in the entire domain. Okay? So for a linear function, there's only one intersection in the entire domain. And then for a quadratic, the same principle holds. Okay? So these two independently are functions. But we have both of them in the same piecewise defined relation. Let's put it that way. So in this piecewise defined relation, what we're going to focus in on is where they overlap, okay? So at this overlapping point, that is the only possibility where you can have one input going to two outputs. Outside that point, you're guaranteed to have one input going to exactly one output because these two are functions in their respective domains. All right, so let's look at a handoff and see what happens. Do we have a nice perfect handoff where one and the other are different output values for two, or do they give you the same output values? All right, so let's take a look at the linear function first. So for the linear, we're going to be looking at y equals 2, x equals 2. So what we're going to do is we're going to take this 2 value and input it into the function and see what the output is. Okay, so y of 2 is just simply going to be x evaluated at 2, which is just 2. Bam. All right, so that's the output value. Now let's look at the quadratic. So for the quadratic, at the handoff point, y of 2 is going to be x squared, right? So it's going to be 2 squared. All right, what is 2 squared? 2 squared is 4. Okay, so let me just put the functions that we're using here. So for the first one, we're using y equals x. And then for the second one, we're using y equals x squared. Remember, a function assigns every input to exactly one output. What do we see happening here? If we want to represent this as a table, what's going to be happening here is as follows. Let's give you a good little visual here using a table so you can see what's going on. So what's going on here is that for this particular piecewise defined relation that we're looking at one point, namely at the linear function, okay, when x is 2, y is 2, right? And at another point at the quadratic function, when x is 2, y is what? 4. Had it been that on the second one, x equals 2 and y is equal to 2 also, that would be a perfect overlap, okay? That would be a function. Or if both of them are 4s or 2s, then that would work, okay? But in this particular case, you have the same input going to 2 different outputs. Is this a function or not? The answer is no. This is not a function, okay? Not a function. Why? Let's write it down. Not a function. The reason is because one input, namely 2, the handoff point, one input goes to 2 outputs. So if you wanted to use the vertical line test in this particular situation, you're going to see that the vertical line is going to cut the function twice at x equals 2. That's another violation there. All right, so this one is not a function. The first one is not. The second one is not. Now let's take a look at the third one. It's pretty easy to test. This one, you have a graph here of a relation. All we just use is a vertical line test. So let's draw a nice little vertical line. So the question is, if we run this vertical line across the entire domain, will there be more than one intersection? Okay, so if you run the vertical line, this vertical line that we just drew right here, if we run it across the entire domain, if there's exactly one intersection at every single point, then that is a function, because that shows us that for every input there is exactly one input. Okay, this vertical line basically connects the input values with the graph. Okay, so if there's more than one intersection, you have one input value going to 2 output values, and that is not a function. So you see one intersection here, one intersection here, everywhere in this domain. The assumption is that the pattern of this function continues, okay? Following that arrow behavior, there isn't any turns happening anywhere in the future. So you have exactly one intersection every single point, okay? So if that's the case, that clearly shows that it's a function. So let's go ahead and mark the points of intersection just to help you clearly see what's going on here. So 1 second. Yeah. So you see that at every point that the vertical line touches the graph, it happens only once. Okay, so you see only once here. Only for each vertical line, there's only one point of intersection between the vertical line and the graph. Only once, and this pattern is expected to continue forever. All right, look at how the arrow points. It's going to continue forever. So this is a function. All right, so let's go ahead and write his down. Relation is a function. Why is that? Because it passes the VLT. What is the VLT? The vertical line test, which shows that a vertical line cannot intersect the graph of a function more than once. Okay? More than once. If it intersects a graph of a relation more than once, then it's automatically not a function. So you have only one correspondence here. Check. Graph number 3, this relation right here, is the graph of a function. Okay, all right, so we already know what the answer is. The answer is option 3, but let's just take a look at 4 just to make sure we are correct. All right, so whenever you're given ordered pairs, what you do is follow the same pattern with a table. Okay, table and ordered pairs are exactly the same thing, just written in different formats. Focus your attention on the x's. Are there repetition in the x's? All right, let's take a look at this right here. Are there repetition in the x's? Absolutely. You have 3 going to 2, and then you have the same 3 going somewhere else to 4. Remember, a function assigns one input to exactly one output. But in this case, the same input 3 is being assigned to 2 and 4 different outputs. Okay, so we have repetition in the x's. What does that tell us? The relation is not a function. So we know for sure that the answer is option number 3. Thanks so much for taking the time to watch this presentation. Really appreciate it. Don't forget to help support our channel. Tons of support resources can be found at Mathgotserved.com, or just take a look at the links in the description below. Thanks again for watching, and we'll see you in the next video. Goodbye.